Hi, my name is Kim. I'm the field CTO of K8s. K8s is a Kubernetes automation platform. We started the journey with doing cost optimization for Kubernetes. We're doing a lot more, and one of this is container live migration I want to show you today. But first of all, set the scene a bit. And I would like to understand who's using Kubernetes of the crowd. Okay, I see a lot of hands. That's great. Some weeks ago, I had a AWS meetup, and I'm talking about Kubernetes, and then I realized, okay, maybe 10% are using Kubernetes. So could be a bit boring if you don't know how Kubernetes works. So yeah, Kubernetes is easy. Do you agree? Kubernetes, easy framework, lightweight, yes and no. So we saw all Kubernetes is doing one thing really great, container orchestration. This is where it's built for. But then we see for all other part, the CNCF ecosystem is growing and growing. So I have to put a lot of tools together and I need to handle the zoo. And also what we see very often with clients, how to handle the zoo. Do you want to do this with your CLI Ninja skills? Or do you want to use automation? For sure, we want to have automation. And we have the year 2025, and still there are people outside, they think automation kills their job. I was speaking with a prospect some weeks ago, and they're doing all of stuff manually. I say, why? What are you doing here? Yeah, because I don't have time to automate things. Say, yeah, that sounds like a the chicken egg problem, but no way. If you want to be successful in environments like Kubernetes and all these virtual layers doesn't make it easy, you want to have automation. Kubernetes gives us a lot of built-in features to automate things, to do it in the right way. We are speaking about infrastructure autoscaling, speaking about horizontal and vertical autoscaling of workloads. There is a lot of more stuff built in. People has to use it. People has to understand how to do this. Because what we need to be clear, Kubernetes isn't efficient per default. There's a lot of potential to do things wrong. I have a different talk tomorrow to speak about how to make Kubernetes in the wrong way. And what we see very often is that clusters are horrific underutilized. This is a report, I forgot to add the QR code I see, is a report we are generating every year. And what we see, 10% of all the CPUs existing in Kubernetes clusters are really in use. That means we are paying for 90% of CPUs, which are completely garbage. Nobody's using them, but we have to pay for. So let's see what Kubernetes gives us for ways to optimize clusters. And we start with infrastructure. Infrastructure is the easiest part. We know what is generating cost. Infrastructure. It doesn't make any difference how much resource you are requesting and using. If you have infrastructure provisioned, you're paying for this. So we see that Kubernetes is not bin packing workloads out of the box. So we're having a lot of underutilized nodes. But Kubernetes gives us autoscaling for cluster autoscaler, Carpenter, proprietary solutions like K8s, which can fix this gap for you. You're having an intelligent solution which is bin packing your workloads, checking which pods can we move to a different node. Movement of pods in Kubernetes means we kill them and they start on a different machine. That's why we need multi-replica. That means the application needs to tolerate this. Otherwise, we are creating a downtime. We are losing a state. This is what we want to avoid. And if we are doing our things good, we have a before and after scenario like this. We see all the autoscalers are really great in fastly scale out. The problem is the downscaling. Applications shrink, but Kubernetes do nothing in your cluster. So you end up, you see the blue line with a lot of resources provisioned, but nobody's using them. You have to pay them. So we want to have strong bin packing algorithms in place. We want to have smart instance selection in place so that we have the yellow, like what the application is using, close to what we are provisioning to not wasting a lot of money. Another problem, how to generate things like this or create a problem, is instances in public cloud. In AWS, in Frankfurt, there are roughly 600 instance types. No human is able to have the full overview, which instances are available, what is the price, what are the specs, what could be the best instance for my workload. So people are just relying on M, C, R instances and just using them. So maybe there are much better fits available. Nobody has an overview. So we need an intelligent system which is doing this for you. On the other side, which kind of instance do we want to use? On demand, do we have reserved instances or do we have spot instance? The percentages are not 100% like this, but long story short, reserved instances can be dangerous if your system is changing a lot over the runtime. You make a commitment, you make Jeff Bezos more rich, but maybe you commit to to resources you never need. Or your demand is changing. You're committing to M instances, but you realized after a half year I need R. So we have the on-demand instance, and then we have Spot is perfect. AWS, Azure, Google, they give you a high discount for Spot instances to use them. Perfect, like 10%. But the problem with Spot is I can get really cheap instances, but there is no guarantee that I can keep them. So the hyperscaler in AWS, 2 minutes ago, they inform you and say in 2 minutes we will kill these machines. We don't care what's running there. Azure is 30 seconds, so it's much versa. And so we need a way to handle these interruptions. So we need to make sure that the new node comes to take over. And on the other side, we need applications who tolerate this interruption. If I have a stateful application running on Spot, could be a bad idea because you will lose your state. Create a downtime, and we don't want this. Also, interesting for Spot, not so many people are aware of this. You're buying an instance for price X, but over the runtime, the Spot price increase. So worst case, unrealistic scenario, but running a Spot instance for 5 months, the price will be 10 times higher than you committed in the first moment. So all of this is what we want to do with infrastructure in a high level. We want to make sure that we have intelligent solutions there using autoscaling. Don't manage nodes manually. Don't sit there and think about, okay, I think we need 6 nodes in my node pool right now. We have a gap, monitoring informs me, I make 7 out of it. Having systems which are sizing your cluster based on the real usage. This is what we want to have. And infrastructure is great, but our workload on top needs to rely on this. We need to take care of both layers, and both needs to be aligned. Also for this, how to scale workloads efficient. Kubernetes has 2 built-in solutions, horizontal pod autoscaler, vertical pod autoscaler. What is the difference? Horizontal pod autoscaler scales horizontally, like we are checking what is the load of our workloads, and if the load increase, the HPA is able to add more replicas, so the application needs to tolerate this and handle this. So we can scale out, make sure that we are handle storm. We see the utilization goes down. Kubernetes has the possibility to remove replicas. And so we have a very efficient scaling system. Vertical pod autoscaling is like we can optimize the requested resources based on our usage. You have, for example, how does people do request definition? I want to define a request. I have no idea. I just select something. Is it working? Okay, perfect. I will never touch it. This is what we see very often. So people think, maybe my pod needs 1 CPU to run. The reality shows us 0.1 should be enough. So we are burning money. We are burning resources. The VPA helps us to dynamically scale this. You can combine these 2 solutions together. Kubernetes documentation tell you HPA and VPA together. Be careful. And that's true. You need to make sure that your configuration is not conflicting, so that your VPA size your requests down and the HPA goes crazy and start 500 replicas. So if we are combining all of these solutions, we will end with a scenario that we have a strong bin packing in place, selecting the right instance types, having a way to vertical and horizontally scale pods. So we have an option to get a very small cluster, which is in a very good utilization. So we are saving a lot of money, and we don't need to take care of them. I don't want to babysit my cluster. I don't want to babysit my workloads. So with all of this, everything is awesome. We are good. We are done. Nice? Sadly not. Because Kubernetes is a nice tool. It's a nice platform, but we still have the same problems what we had in the classical way. We're just doing things more complex now. So that's why Cast.ai created these container live migration. But what does this mean? Cast.ai's container live migration is a way to migrate pods between nodes, move a pod from one node to another without a downtime in the same cluster. It's not helping you migrating things from cluster A to cluster B, from on-prem to the cloud. We are speaking about stuff inside of the cluster. I want to get rid of a pod from one node and moving them over without restarting them. How does it work? So let's see. We have 2 nodes. I have a pod running, pod foo123, and I have an IP address ends on 15. I want to move this pod, and I want to say I can manually trigger them, or I have the platform which is managing this for me, like a spot interruption is coming. Spot interruption will kill my node A. I want to get rid of the pods in a safe way. So the event is coming. The pod needs to be moved. What Cast.ai is doing, we are starting the migration. We are creating a new pod, a shadow pod on the new node, which you see the name slightly change. We're adding the suffix, clone 1. but we keep the same IP address. And we are using the same methodology like VMware was doing this 2000 maybe with vMotion. Mirror the memory. If the memory is completely done, we can take over the responsibility. The application contains exactly where they were before on node A, but now we are on node B. This gives us the potential to get smaller cluster. We can bin pack each workload. We can run each workload on spot. This is without interruption, without downtime, no restarts. And in a few phases, I can see people think, why do I need this in Kubernetes? Because at the end, Kubernetes doesn't have this implemented. Why? Kubernetes say, this is an HA feature. Must be done in the application. The infrastructure doesn't care about this. The Kubernetes layer doesn't care about this. But we see there are very much use cases in the field. A very problematic one, especially if we're looking for enterprise. In enterprise business, Kubernetes is still a new kind of stuff. There's a lot of lift and shift. And they lift and shifted from on-prem to the cloud. And then also we lift and shift from VM to Kubernetes. So instead having a VM running somewhere, I have a large pod running in Kubernetes. It can't scale horizontally. It takes 10 minutes to start. We never have any benefit out of Kubernetes. There are companies out, they are running 95% workloads like this. I say, why the hell are you using Kubernetes? You don't get any benefit out of it. You just have a different abstraction layer in between. Or then also extend your spot footprint. I want to offload all my workloads to spot to save money, because the problem is the interruption. But with a solution like this, I can live migrate my pod from spot to another spot, from spot to on-prem if no spot is available. I can offload all the stuff there. Long-running jobs. Right now I can't do this. Long-running jobs are on demand because they are running 20 hours. If they are interrupted after 19 hours, that's a problem. With a solution like this, we just move it over to a different node and the job contains there. It's a pretty new feature we have. It's part of the K8s suite. For EKS, we have it right now. It's G8 yesterday. For GCP, GKE, it's coming very soon in Q4, and AKS will follow next year. It's a lot of theoretical stuff I would like to show to you. Before, I need to make a short note. We are sponsoring of these events, so we have sponsored your conference shirts, and at the back, there is a link. If you go to this link, you can join a raffle, win some fancy Lego stuff, or if you don't like Lego, you're on the wrong conference for this. But if you don't like Lego, or you say, I already have this, you can also get an Amazon voucher for this. So let's see it in action. Enough theoretical stuff. Let's play with it. And play is a good word. I want to do it with Minecraft. And let's see how this works. So first of all, no. Yeah. It helps to close the, no, go away. How to close the full screen. Here we go. So I hope the font sizes for the font size are okay. So let's set the theme, what we want to see. So this is a demo environment we are using right now on all the conferences, probably at the booth, to catch people. Minecraft is a good way to catch people. Who's playing Minecraft? Really? Why? It spends so much time to build this demo, and I'm sitting there and say, what the hell? Why spending people so much time with Minecraft? But okay, it's a different story. So all this environment is running in my Kubernetes cluster. I have 3 pods running. One of them is this Kuberite pod. It's the Minecraft backend server. I have the Minecraft web client, which is embedded in my demo app, so we can join the cluster, start playing. On the other side, we see some stuff to give you information about the system. For now, we have zero active user. If you want to join, you can scan this code. The game is playable with your smartphone, so you can see that it's not a fake. You can join this story. You can see which nodes I'm running in my cluster. The green one is currently running the backend service. And then I want to trigger the move. First of all, let's join the game. We're connecting to the prepared node. Here we go. We are in a random environment, in a random, okay, it's an interesting map. So we can see I can play and stuff will happen. Okay, so to show you that it's real, let's kill this pod for a moment. Did you see? I will kill the pod. A new pod will be starting. The old pod will be terminated. I get a new IP address for the pod. It takes roughly 30 seconds until the pod starts. And then we will see we end in a different world. So we are losing completely the state stored in this pod. And we are joining the game again. And then we will do this in a live migrated way to show you the pod is switching the node. It keeps the IP address, but we are not losing any state. So pod shows ready. Let's see if we can join the server again. So you see the map changed. We are in a new world. We lost all the state. And then I will toggle on auto move. So what is it doing is every 20 seconds, a new custom resource definition will be created and the pod will be randomly migrated to one of the other nodes. And I'm just let the game run. And we should see there one of the nodes getting yellow. So this is the new target node. We can see a new pod is coming. Ends on clone 1. Keeps the same IP address. The old pod will be killed. The game is not crashing. The next 20 seconds, the same will happen. And it's just a nice way to demo it. And it will work with all of your applications. So if you're running applications which can't tolerate an interruption, if you have workloads running in your cluster which can't tolerate an interruption, restart, something like this, you don't want to wait for the next maintenance window because you need to update the machine, but there's a single pod running on this machine. We need to migrate them. Migrate means restarting Kubernetes. We have to wait for a 11 p.m. downtime window. With all of these problems are gone with a solution like this. With this, I'm done. I'm in time. That's the first time I think that I'm in time. Yeah. Do you have any questions for this? Yeah. Let's start. Okay. We need to hold on.
Great talk. Fascinating concept. So what I'm looking at is when I have an event that needs to be triggered that may relate to a pod that's not the one that's causing the problem. So I'm thinking something like I've got two applications running inside of a single pod. One of them is a noisy neighbor. It's taken over all my memory access.
Yep.
Can I generate or automate the way of moving the one I need to move, which is just not being able to run because of memory space versus CPU space?
Yeah, this is possible. So if you have multiple containers in one pod, then for sure we have to move the complete pod. If you have multiple pods running on the same machine, okay, there's a noisy neighbor event happening, we can move these, the problem creating pod or the affected pods. You can control this, what should be triggered to move to a different machine. Also for this, we are capturing, I forgot what is the name of this metric. So the Linux kernel gives us metrics about what is the CPU threshold, also network, storage, all these information. They will take into account for this. Sure. Let's go from right to left.
Yeah, thank you. Thank you for the talk. My question is more related to AWS ecosystem, so K8s, and about stateful sets. When you have some kind of persistent storage, like EPS volume, and your application is running in multi-zone. So when you do the move, is the Cast AI zone aware? If you move like the pod to, I don't know, another zone and the EPS in a different zone, then you will just...
Exactly. So in this case, AWS will not allow you to migrate or to mount the PVC in a different availability zone. We are aware of this. So the system will only look, do we have a capacity in this availability zone where the pod is running right now to move it there on a different node. It's also a requirement for keeping the same IP address. AWS doesn't allow you to move the IP address between different subnets. So it will create a routing issue. So also there we're looking inside of the same subnet. If you say, I don't care about the IP address and I can live with that the data is copied, then you can do this as well. But depends on your amount of data, then it's not live anymore. If you have to wait 2 hours until the PVC is copied.
So when it transitions over to the cloned pod, I noticed every time it's happening, the previous pod is saying error, then crash looping.
Yeah.
Is that because the Kubernetes API doesn't like what you're doing?
Exactly. This is because the Kubernetes API doesn't want what we do. See, okay, there's something error. This is the moment where we switch over the liveness to the new pod, then the old pod getting into an error state, and our controller clean it up.
Have you spoken to the maintainers about having some kind of support for this behavior? Or
yeah, we are working with a lot of people there also to adapt this to native Kubernetes as well as other providers as well to fix this issue. But at the end, it's not an issue. It's just a normal way how Kubernetes detects these things. And it's not a problem at the end. There's another one.
Thank you. My question is, you showed initially regarding about the cost optimization front in the beginning.
Yeah.
When you move one pod from one machine to the other to provide a best fit kind of a strategy, So does it happen? Is there like a trigger or an automation similar to what Carpenter does automatically, or is it something like manually you have to shift it?
No, this is the platform will do this for you. It's you can use the solution together with Carpenter. You can rely completely on Cast AI. This is up to you.
All right, thank you.
My question is about storage, and how do you make sure that when you're live migrating a pod which has storage attached, that happens in a consistent manner without losing any or corrupting the file system?
From migrating storage is also the CSI provider needs to allow us to have multi-attachment. Otherwise, you have a delta, because then we have to unmount it first on one node, mounting it on a different node. It can take a bit. We are making sure that the file system is synced before we are mounting it off of the previous pod.
So if the CSI provider doesn't support it, you
Yes.
can't do live migrations.
Maybe you already covered while presenting. While moving, at least especially in the demo, you wantedly stop the original pod, or Cast AI automatically detects it is going down, then I...
Cast AI is doing this. So for the migration happened like this. We are starting the shadow pod on the new machine. The memory will be mirrored. If there is 1% roughly left of the memory, the pod will be frozen, the original one. The last delta will be synced. The pod takeover will be alive on the new machine, keeping all the settings. The application continues there, and then the old pod will be killed. This is an integration happen directly on the container D level.
What is the event which gives go to Cast AI to mirror?
It's a custom resource definition, so you can create the migration object manually. If you say, right now, I need to move that pod, this is what I'm doing here right now, of just creating this object and tell this pod should be run on this node. It's also integrated in the other ecosystem we have. We spoke at the beginning about bin packing cluster. The bin packer has the option to do this as well. If the bin packers see there are three pods running on this machine, if I can move all the three to different nodes, I can get rid of a machine. The bin packing algorithm will trigger this migration, creates this CRD so that the pods move over to the new target node, and then we can delete the machine.
Maybe I'm not putting it right. Thanks for explaining. But can it auto-detect something is not good on the source, on a pod, and then...
On a pod?
Yeah, if there's a pod.
Yeah.
And is it like something we trigger that move this, or is it something it observes the pod, something is not good on this node, I will move this pod to another node?
So it's like we want to get rid of nodes, we see lack of resources. Also, what's helpful is Kubernetes 1.33 promoted the in-place pod right-sizing feature to beta. So this allows you to change requests and limits during the runtime. In older Kubernetes versions, you need to restart a pod for this. In the new Kubernetes version, you can allow Kubernetes to change this. If you're running in an old version, you can't use this feature. But with a feature like this, you can also, because a new pod will be technically created, the new pod can start with a different request and limit. So we give you also this capability if you are running older versions.
Great talk, thank you. I suppose my question was just, are there any use cases where this won't work or it's not recommended for?
I'm pretty sure there are use cases. I can't give you an example right now. It will be problematic if you have really big pods, like a lot of memory, which is changing rapidly. Because then we are in the situation why SAP HANA is still not live migratable with VMware. If too many changes are there, you will never be able to sync the delta. So these applications can be problematic. No other question? Okay, then I say thank you for your time. Have a good day.